the second question. It says this. Show that, I think it's 10 inverse of that. Okay, so this is part B. Now I don't know what you think when you look at that question. It looks like, it's like, why is this even a separate question? Like if this is one line, right, and this is the last line of my previous thing, and I have to show that, what would you think is the most instinctive thing to do? I could just do tan inverse of both sides, couldn't I, right? If I do tan inverse of this, I should get this, right? If I do tan inverse of the other side, I get this, and that's it. It's like, where's the, what show? It's I just wrote it down, is that it? Now, here's the reason why this is a show question. We simply cannot write this. There is a problem, we've missed something, okay? There is more than just one line between these two. The question is, why? Why might there be a problem just trying to go from here to here? I've alluded to it already by something that I've written on the board. Can anyone work out where might there be some issues in here? I introduced this idea here, right? Because I said, we already know, in inverse trig, more than any other topic, right? You've got to be careful for your restrictions. Your restrictions change everything in inverse trig. They don't usually do that in most topics, but in inverse trig, they do, right? Now, there's a domain problem in here. There is a domain problem in here, right? Going from this line to this line, we've all assumed that if I take tan inverse of both sides, it's okay. Can I do that? Can I just take tan inverse of both sides and it works? Particularly have a look at this left-hand side over here. Okay, is tan inverse of tan pi on 2 minus theta, is it always equal to pi on 2 minus theta? And the answer is sometimes. And the question is, what's the sometimes? What's the sometimes? For what values is this actually true? Okay. Now, if you remember, when we graphed, this is the inverse one on the outside and a regular one on the inside. When you graph this guy, okay, this is equal to x, but only sometimes, right? What does it look like? What does the graph look like? I think it looked like this, didn't it? Something like that, okay, that jagged sort of sine curve with straight lines, which is weird, okay? So you can see in this spot here, that's y equals x, isn't it? It passes through the origin with the right gradient. But the rest of it, none of that is y equals x. It's only in this little section here, okay? So the question is, what would this thing look like? What would tan inverse of tan look like? Now, let me try this out, okay? Let's get your calculators out for a second. Where am I going to do this? I'll do it over here. Okay, now, with your calculators, let's see if we can not necessarily draw it, because that would take a while, but do enough investigation that we can work out where this is going to be useful to us, right? Let's try a value. Give me a value, anything.
1.
1? What's tan inverse of tan? 1. Make sure you're in the right mode.
1.
Is it 1?
Yes.
Okay, that's good. Alright, give me another value. 2. What's tan inverse of tan 2?
2.
2. Okay, give me another value.
3 pi on 2.
3 pi on 2? 3, 4? 3.
More to here.
Okay, is it going to keep going?
No, it won't keep going.
Why not?
90 is necessary.
Mass.
Are you in radians or are you in degrees? Oh, come on, guys. Let's try this again. Actually, I know that that'll be okay.
I thought we wanted to be.
Give me some radians. Did I tell you to be in degrees?
Oh my god.
You didn't say
I didn't.
anything.
Oh, well, okay. Radians. All right. Can we be in radians, please?
Yeah.
Yes?
No.
Still working? Yeah. Okay. So now what?
Yes.
Give me a value.
It's true, doesn't it?
Yeah, what does, okay, so if I put in this, what do I get?
Negative.
1.1, some rubbish.
Yeah. Basically.
We don't get this, okay? Something else.
Pi.
Pi? What do you get?
0.
Yeah.
Okay, so we've just broken through this. Tan inverse of tan something, right, doesn't necessarily give you back something, okay? I'll save you some time. I'll draw you what tan inverse of tan x looks like, okay? It roughly looks like this. Okay? It's kind of weird. In fact, do you remember what happened over here? We kind of got a straightened out version of sine, didn't we? Yes? This almost looks like a straightened out version of tan. That's a bit funny, isn't it? Where are these discontinuities? At pi on 2. Is it equal to the top or the bottom? Think about it. If it's pi on 2, it doesn't equal either of them, does it? It's a proper, it's not just a I'm equal to 1 but not the bottom. It's just, it's a complete whole, right? I can actually drop through there if I put a value of pi on 2. Okay, so if I've established this, right, there is a portion where this is true. Which portion is it? From negative pi on 2 to pi on 2. That's when it works, okay? Alright, so let me see if I can pull this all together, okay? I want to look at, where am I? I want to look at this thing, okay? I want to take tan inverse of both sides, okay? So I want to consider tan inverse of tan pi on 2 minus theta, okay? I want it to be equal to pi on 2 minus theta. Where is that the case? And the answer is when that angle is between negative pi on 2 and pi on 2. Is that okay? Does that make sense? I mean, I called the angle x here, but this angle is called pi on 2 minus theta. That's the whole angle, okay? So therefore, I'm going to need to include a restriction over here. This one. Yeah, that's okay. Oops, not inclusive. It breaks. Okay, now that is the place, that's the domain where I can say tan inverse tan that does give me that straight back, okay? Now that's a really weird way to write a domain, isn't it? Can we tidy this up a little bit? How would we do it? Any suggestions? I can take away pi on 2 from everything, okay? So that's going to give me on the left-hand side, it's going to give me negative pi. You'll have negative theta in there, and you'll have 0, won't you? Okay. What should I do now? I could multiply through by minus 1, right? That's going to change all the directions of the inequalities, aren't they? Right? So it would look like this. Pi, theta, still 0, okay? But it's a bit weird writing them from big to small. That's what these mean, right? So let's turn it around. Is that okay? Is that all right? Okay, good. So now I know when this is true, okay? But the question didn't say, show that this is true, right? For only certain values. It just said, show. No conditions applied. Or are there? Are there some conditions on this? Is theta restricted?
Yes.
Where is it restricted? Look, it's on the board. Where is, what on the board tells you that theta is restricted? Can you see the whole board? I haven't rubbed off anything. Which bit specifically? Can you tell me? Ah, okay. Right there. Now, what restriction does that imply? Just that one line on its own. Theta equals tan inverse of x. The restriction it implies is a range restriction on theta. Right? Because theta can't just go anywhere. It's actually locked in there, right? When you draw tan inverse. Where's it locked between? From negative pi on 2, not inclusive because they're asymptotes, aren't they? To pi on 2. Okay, now that's good, but that's not good enough. I need this, or at least I need to be in there, right? So there's something else. What else? Ah, x is positive. X is positive and this is true, right? So therefore, let me draw this guy for you. It'll be so much easier to see. What does tan inverse look like? Well, you've got your two horizontal asymptotes, right? Right. Now, if I drew the whole thing, you'd get this shape. And just like you told me, it's between a negative pi on 2 and pi on 2. Aha, but I don't want the whole graph, because the very first thing I wrote down was x is greater than 0. Right? So therefore, not inclusive, I'm up here. Okay? So in fact, I'm even better than this. I'm actually from 0 to pi on 2. Okay? So what this means is you have to be really careful in the way you think about restrictions. Okay? From the get-go, as soon as we set up the question, they say, forget about every value of theta except for these ones. These are the only ones I'm interested in. Okay? And then you start doing some work, and when you get to a restriction like this, you think, now, the values that I'm interested in, are they within these values? And the answer is yes, they are. Right? Because 0 to pi on 2 is smaller than 0 to pi. Okay? So that's why I can make this statement. Right? So, let me come back to this line, okay? I can say tan of pi on 2 minus theta equals 1 on x, shown above, because that's what I proved in part A. Okay. Now I can say, I should include this line, don't skip this line, where you actually do tan inverse of both sides. Whoops, sorry. At this point, I don't need to bring any domain restrictions in. It's when I take this and get rid of, evaluate the tan inverse tan, right? When I do this, I need to be able to justify why this can magically turn into this, because it's not always that. Outside this domain, it's equal to other weirdo looking things, okay? I can say this equals this as, and then I bring in our domain restriction as 0, theta, pi on 2. It is true. This line does go to this line in this domain because that's the one I'm interested in. Okay? So that's why show, right? There isn't just one line between here and here. I suppose in order to justify this, you know, this working that I've included here and actually getting the domain where it works is actually invaluable to include, just like I have. Okay?